This is question 20 from the 2022 GCSE Mathematics Higher Tier exam and tests our understanding of gradient and equations of a straight line. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. We've been given a circle whose center has coordinates -1, 3, and a point A on its perimeter with coordinates 6, 8. And the question asks us to find the equation of the tangent to the circle at point A, and specifies the form of that equation. A tangent to a circle is a straight line that touches the perimeter of the circle at exactly one point, and the point of tangency is the point where the line and circle touch. A tangent is always perpendicular to the radius of the circle. The gradient of a straight line is a numerical value that describes both the direction and steepness of that line, and can be calculated using the coordinates of 2 points on the line. Answering this question is a 3-step process. To begin, we need to find the gradient of the line joining the 2 points we've been given, before finding the gradient of the perpendicular line. Then, using that gradient and the coordinates of point A, we can find the equation of the tangent to the curve. The line joining the center of the circle and point A represents the radius of the circle. The center has coordinates -1, 3. And point A has coordinates 6, 8. The gradient of the line joining 2 points is found by dividing the difference between the y-coordinates and the x-coordinates. In other words, y2 minus y1 divided by x2 minus x1. For 2 points with the coordinates x1, y1 and x2, y2. So, if -1, 3 is x1, y1 and 6, 8 is x2, y2, then x1 is equal to -1, x2 is equal to 6, y1 is equal to 3, and y2 is equal to 8. Substituting those values into the gradient formula gives us 8 minus 3 divided by 6 minus -1, which evaluates to give us a value for the gradient equal to 5/7. the tangent to the circle is a straight line perpendicular to the radius. If the gradient of a straight line is m, then the gradient of the line that's perpendicular to that line is the negative reciprocal of m. In other words, minus 1 divided by m. We know that the gradient of the radius is 5/7, so the negative reciprocal of 5/7 is minus 1 divided by 5/7, which is minus 7/5. So the gradient of the tangent to the circle at point A is minus 7/5. We know the coordinates of point A and the gradient of the tangent at point A. So we can now find the equation of the tangent. The equation of a line is given as y minus y1 equal to m multiplied by x minus x1, where x1 is 6, y1 is 8, and m is minus 7/5. And so, y minus 8 is equal to minus 7/5 multiplied by x minus 6. Multiplying both sides by 5 eliminates the fraction on the right side of the equation, giving us 5y minus 40 equal to minus 7 multiplied by x minus 6. And expanding the bracket gives us minus 7x plus 42. To express the equation in the form that the question tells us to, we need to do two things. Eliminate the minus 7x term and the 42 term from the right side of the equation. That means we need to add 7x to both sides and subtract 42 from both sides. That gives us 5y minus 40 plus 7x equal to 42. And to finish, 5y plus 7x minus 82 equal to 0. Answering this question successfully relies on our understanding of calculating gradients, understanding perpendicular line properties, and manipulating linear equations. So the equation of the tangent to the circle at point A and the answer to this question is 5y plus 7x minus 82 equal to 0. Read our blog at mathsdepot.com for more maths content.